Hey now, this is a video for solving the Coulomb's law equation, which you can see on the screen that I'm showing you. That is the equation that is Fe equals K Q1 Q2 divided by R squared. And this is basically the equation to find out what the electrical force is between charged objects. And so using this equation, we're going to note that Fe stands for the electrical force. That will be in newtons. R is the distance between centers, that is in meters. Charge is the size of the charge in coulombs of each object involved. There has to be two. And then K is the electrostatic constant, and that will be the exact same number we use every single time when we solve for this equation. So I'm going to demonstrate how to solve number one on the practice problems I gave to you, and you can use this for help. So I'm going to write down the equation first. Again, it's the electrostatic force equals K Q1 Q2 divided by R squared. So in this case, we're solving for the force. Okay, so K is going to be that extremely long number from the front page of the reference table. So that is 8.99 times 10 to the 9 newtons times meters squared per coulomb squared. I'm going to set these stuff in parentheses just to make it easier to look at. Okay, we multiply that by the size of the first charge. That would be Q1. And according to the problem, it says that the first charge is 1.5 times 10 to the negative 5 coulombs. And it's a positive charge, so I'm just going to add a positive sign in front. The problem actually says that there's two positive charges of the same size, so I'm going to write that number a second time. Positive 1.5 times 10 to the negative 5 coulombs. And so all of that is what the numerator should look like when you're plugging in the numbers with the units for this problem. So we divide all that by the distance between them, and as given the problem, that's 0.15 meters. And so that's going to be squared. So I like to use parentheses for that. And then almost as a little reminder, I put parentheses on the outside because when I plug this into the calculator, I like to use double parentheses so it turns out the right answer. All right, from there, we're going to go to our calculator here. So I'm using the one that you should be familiar with, but you got to figure out how to do this on the one you have. So I start with parentheses. This is going to be 8.99. I'm going to use that second e function, and that's going to give me times 10 to the whatever power I want. This one happens to be to the power of 9. Okay, close those parentheses. I multiply that by the size of the first charge, 1.5. That was times 10 to the negative 5. And then I multiply that by the size of the second charge, which in this case just happens to be the same. Okay, I'm going to hit enter, and that's going to give me what everything in the numerator is equal to. And I'm just going to divide by what's in the denominator, the distance between the squares. So here I use double parentheses. The distance was 0.15 meters. I square that, close that second set of parentheses, I hit enter, and here's my answer, 89.9. Okay? And so when I'm writing my last step here, the electrostatic force is 89.9, and since we're talking about force here, that has to be newtons. Now, because this ended up as being a positive number, that means that both charges were either positive or both charges were negative. And so that means the positive sign means that this will be a repulsive force. All right, I hope that helps. Email me with questions.